Factors affecting the mobility of the free electron or the charge carriers. Mobility means how easily the charge carriers can move in the crystal under the influence of the electric field. So we know that this mobility is given by the ratio of this drift velocity to electric field, and this is equal to E into tau upon m, tau the relaxation time, m the mass of the electron. Material. The mobility varies from conductor to conductor depending upon their material. For example, the electron have more mobility than the holes in the semiconductor. Crystal structure. The crystal structure means the arrangement of atoms in the lattice. And all the crystals have the impurities, defects and the imperfections, and these causes to diffuse or to scatter the charge carriers more easily. So they decrease the mobility of the charge carriers. Temperature. This relaxation time is inversely proportional to the temperature. So mobility is also inversely proportional to the temperature. It means that when temperature is increased, the mobility decreases. This is why, because when temperature is increased, the thermal vibrations becomes more agitated and they become more frequently. So they scatters the charge carriers, and that mobility of the charge carriers decreases. Electric field. At low electric field, the mobility is constant, but at a high electric field, the mobility increases sublinearly or asymptotically towards the saturation velocity called the maximum velocity. Mass. As we have mass, this mobility is inversely proportional to the mass of the charge carrier. Heavier the charge carriers, low is the mobility. 6 is doping. When the doping is done in the semiconductors, they decrease the mobility of the charge carriers because they produce the scattering of these charge carriers. So the mobility decreases. So this mobility n mu is inversely proportional to 1 upon inversely proportional to ND. ND the doping concentration. So these are the factors that affect the mobility of the charge carriers. Thank you.